recorded, so quiet. So here's the first one. You'll have a couple of these just like this on the summative tomorrow. Okay? Here we have our fake ratio. Very good. Okay, now we're going to do our proportion. Now, what number goes on every unit rate proportion? Alex? And how do I know this is a unit rate, by the way? What word is a dead giveaway that we're even doing unit rate here? Owen? Right there's your word. It's a dead giveaway right away. Now we've just got to put our labels on. So are we figuring out the amount of hours per mile or miles per hour? That's what we've got to figure out. Are we talking about 1 hour or 1 mile here? Jimmy?
Miles per hour.
So we're going to do 1 hour, which means hours there, miles there, miles there. Now we're going to put our fake ratio on right there. Everybody got that?
Yes.
So then we just go up and look and see, okay, well, 12 miles has to stay with miles. 4 has to stay with hours. What are we doing to our number of hours? Divided by 4, so what do we got to do to our number of miles? That would be 3 miles per hour. Everybody see that? Pretty easy? Please be listening. Here's the strategy I want you guys to see. Okay? The strategy here would be to do your edge pieces. Now, I already got a big blue box listed there. So, well, you know what? I'm not even going to do it. I'll just do my box up here, just like I always do. There's my box right there. Okay? What is that saying? What is the meaning of that particular ratio right there? What is the meaning of that? Skovic?
Fake ratio.
Yeah, that's my fake ratio. So what does it describe the meaning? Like when I ask you to describe the meaning of that ratio, what could you say? Big Will?
That there are 5 balloons, 6 stars.
So what I like to do is I like to write that out. 5 balloons, 6 stars. Right? Now, the way I would really like you to do this come tomorrow, because it's a tongue twister. I have to read it a couple times. Mr. Zenker, I think he would agree he had to read it a couple times. Because you read it and you're like, wait a minute. Okay, I'm seeing stars first, balloons first, 5 and 6 are flip-flop. It's not easy. So let me give you a strategy. Okay, what I want to do is I'm basically going to make a little, I'm going to put exactly what Max is saying. I'm going to put exactly what Mike is saying. And that's what I'm going to figure them out right now. I'm going to figure out what each individual is saying. So it says, Mike says that the ratio of stars, do you guys all agree he said stars first?
Yeah.
Okay. And then he gave us the number 5 first. So do you agree that he's saying there are 5 stars, guys?
Yes. Yeah.
Okay. Yeah, stars. Stars. Okay. And then what else is he saying? Then he gives balloons second. So there you go. If he gives balloons second, then that means 6 must go with balloons. So 6 balloons. Right? Everybody got that so far?
Yeah.
All right, let's go down and figure out what Mike... Oh, I got these backwards, don't I?
Yeah.
Dang it. Shoot. Sorry. Jeez. See? Even me. I get to go on and I read it wrong or whatever. So this is actually what Mike said right here. And then Max was saying this. Okay, so what's Max saying? He's saying the ratio of stars was listed first. So doesn't 6 go with stars, guys?
Yeah.
6 stars. And if anybody wants to use a highlighter on the test for this question, I'm fine with that. Or you could do like a rectangle around this one and a triangle around this one or something. You know what I mean? Like you could do different things to help you to be able to put them together. And then Max listed out balloons second. So that means 5 goes with balloons. So now we just have to go up and say who's right based on our edge pieces up here. Huh?
Max.
Well, obviously Max is, right? Because he is saying 6 stars, which we have, and I wrote starts up there too, evidently. And he's saying 5 balloons, which is how many we have. So Max is absolutely correct here. The reason why? Very simply, if you write this on the test, I'll count it right 100 times out of 100. Because order matters. Because order matters. That's it. The order in which you list a ratio matters. All right? Okay, look here, guys. So what a part to whole is pretty easy to explain, I think, and I think Miss Farmer did a great job with this. Here's my question to all of you. Do those 30 boys, I see people erasing and still writing. I need you with me. 30 boys. Do those 30 boys make up those 200 people? Those 30 are part of the... Those 30 are part of those 200. That is why that one is definitely a part to whole, right? Whereas this one, do those 42 teachers make up the 295 students? Is that number included in those 295? No, so that would just be A, part to part. Okay, and finally, do those 28 girls make up those 30 boys? No, so that would be A, part to part also. Everybody got that?
Yes.
All right, good. Let me just record it. So just watch. I don't want you writing, I want you watching. Okay, are the following ratios equivalent? Show at least two methods. At least two methods. So here today, we're going to show three methods. Now there is the big three and then what I call the little fourth, right? The big three and the little fourth. So we're going to do this one. Like I said, I don't want you writing anything. I just want you watching right now, trying to grasp what I'm saying. Okay, so here's our two ratios, right?
Yeah.
Who remembers one of the big three? Owen?
Cross product.
What's called cross product. Now, what's a product? Cedric? Answer to a multiplication. And how we use cross products is we simply just multiply them diagonally, right?
Yeah.
18 times 6 is 108. 9 times 12 is 108. So far, are those two ratios equal to one another?
Yeah.
So right now I'm going to put a check mark by that. That's one. Give me the second of the big three. Big Will? Simplify. Okay. Now, how can you simplify in your calculator? Well, you can do 12 ABC 18, right? Which is going to give you the ratio. It's going to look like a fraction, but it's a ratio of 2 to 3. When I do 6 ABC 9, that's going to give me the ratio 2 to 3. Did it give me the same simplified ratio?
Yes.
Okay, so right there, did we prove them to be equal so far? Good. Okay, let's go to number 3 now. What's the third of the big three, Prawn? Divide them, because all fractions are division problems, or in this case, ratios, but it works the same way. Okay, so what we're going to do is we're going to do 12 divided by 18. No, I don't want you doing this. We don't have time. We will never finish the test if we're doing that. Let's use our calculator. 12 divided by 18. It's got to be first number divided by second number, though. When you do that, you're going to get 0.6 with a bunch of sixes, so we're just going to write it as 0.6 repeating. We're going to do 6 divided by 9, which is going to give us 0.6 repeating, right?
Yep.
Did we confirm that they're equal based on the divide method?
Yes.
So there's the big three. And I want you to use the big three now, because let's say you get to the test tomorrow, you forget one, are you still okay? But ultimately, if you show all three, you've covered all your bases. So let's try to use the big three. Now, for those of you asking about the little fourth method, the little fourth doesn't work all the time. That's why I don't care for it. Okay, the other three work all the time. The little fourth does not. And that's where you can just simply look at this and say, oh, well, I'm just dividing by 2 and dividing by 2, right?
Yeah.
That's the little fourth. That does not always work. I want to emphasize that. Let me give you a quick example. You don't have to write this, I just want you to watch. Let's say I gave you this one right here. 10/15 and 6/9. Is there anything you can divide 6 by or 10 by to give you 6? Is there anything you can divide 15 by to give you 9? Okay, so when you first look at it, do they look like they're not equal? Hello?
Yeah.
Based on the little fourth, are they not equal? Right. But if you use cross products, you learn that, hey, oh, they're both 90. When you simplify them, you get 2 to 3 and 2 to 3. When you divide them, you get 0.6 and 0.6. You guys all get that?
Yeah.
So the big three are the ones I want you to really focus on. I don't really care about I didn't want you to mess with the little fourth. Just the big three. Everybody got me?
Yep.
Okay. We're going to do, okay, this one right here. Go ahead and show your three methods. So I'll rewrite this so we can see it. 9/12 and 15/20. Go ahead. Show me the, at least, I want to see all three, the big three. So again, here on this one, we've got to check. So the first one we're going to do is what I call CP, cross products. Okay, so we're going to multiply diagonally. When you do that, you get 180 for both of them. So far, that proved them equal. Then we're going to do simplify. When I simplify 9 ABC 12, I'm going to get 3 to 4. When I simplify 15 ABC 20, I'm going to get 3 to 4. There we go. We proved they were equal there. Finally, we're going to divide them, and we're going to also get 0.75 and 0.75. You can see that we're getting the same regardless. It makes sense to do all three because then in case you made a mistake, you know what I mean? Like when you're simplifying, good job. So yes, those are absolutely equal to one another. All right. Okay. So this one here, guys. This is that one. Remember that question that was like there was multiple answers? Number 15, I think, on the formative. Okay. This is like that one. There's a couple ways you can do it. It says if Mr. Garrison ran 8 laps around the track in 24 minutes, it would take him 3 minutes to run 1 lap. Now, there's 2 ways to do this. Okay, I'm going to try to show you both without confusing you, I hope. The first way is you can look at it and say, okay, do you agree that that right there is a ratio?
Fake ratio.
Fake ratio, fine. And then do you agree that this right here is a ratio?
Yes.
Okay. Do those 2 ratios need to be equivalent to one another?
Yes.
Why are you writing this? Don't worry. Okay. So if they need to be equivalent to one another, doesn't it make sense to do 8 laps for every 24 minutes? But remember, when you do that, you've got to keep laps on top. You've got to keep minutes on the bottom. So then how many laps are we talking about? Read it. Guys, in the real one. 1 and 3. Does that make sense? If you want to do it that way, now we can just do the big 3 methods. We can cross products, 24 and 24. We can simplify them both to 1 to 3, 1 to 3. We can divide them to get 0.3 repeating, 0.3 repeating. So right now, is that a true answer? Yes, it is. The other way that you can do it, okay, because there's multiple ways. I don't really care. Okay, the other way that you can do it is, do you agree that it's giving us a unit rate down there in the green one? Is that a unit rate right there?
Yep.
So would it be okay if you just went ahead and found the unit rate per lap?
Yeah.
Right?
Yep.
So then we'd have laps, we'd have minutes. We put our fake ratio here, which is 24 minutes for 8 laps. Notice we had to flip-flop this, right? Because that has to go with the same label. Now what are we doing to our number of laps? Dividing by 8. So what do we got to do here? Divide by 8. And that would give us 3. So is that a true statement, guys?
Yeah.
Yes, it is. So either way on that. Okay? Let's go ahead and go to this one. Try this one. I would do method 1 here, which means you have 2 ratios. You have 2 ratios. Why don't you guys just check to see if those 2 ratios are equivalent to one another? But you got to have labels. Use the big 3 methods. Go. Listen. Okay, so if Mr. Smith runs 4 laps on the track in 48 minutes, guys, listen, then this is basically the situation that I have. I have that ratio. I need to know if the other ratio matches it, if it's equivalent to it. So you got to make sure you keep it as laps to minutes, though, because even though it's in that order, we got to put 2 there, we got to put 24 there. Now, can we do cross products?
Sure.
Yeah, 96 and 96, right? I simplify it. That gives me 1 to 12, 1 to 12, right? I divide it. That gives me 0.08 or something, I think. 0.083, fine. 0.083. Everybody understand what we're doing here?
Yeah.
Now, the other way that you could have done it, and I don't even like doing this really because I don't want to confuse you, but that way works. But you could have said, okay, if it's 4 laps for 48 minutes, then you know this is going to be laps, this is minutes. What you could do is you could just pick one of these 2 numbers. You could either put 24 minutes on here, or you could put 2 laps. And watch. What would I be doing to my number of laps here? So what do you have to do to your number of minutes? And if that answer is 24, then you know it's a true answer. Does that make sense?
Yeah.
All right, let's move on. So, first of all, guys, you have to read the question here. Everybody look, please. I still see people writing and going through it. You can go through this again tonight or whatever. You can go home and do this. Right now, I just want to make sure we got it. We know it's going to look like that for both number 1 and number 2. Does everybody agree with that?
Yes.
That's why Mr. Zinker and I can't figure out why it's taken some of us so long to get started. Because you know it's unit rate because I told you, number 1. Number 2, because it says per paperclip. And it says cost, or how many paperclips for $1. Those are very typical unit rates. Those are unit rates, not typical. They are unit rates. Now, we've now got to start building our labels. I still, have labels on there. Okay? We've got to make sure we're now building with labels. I'm not putting any numbers on there until I'm completely got my labels on. So, what's going to be the label? Per what down here? What's it going to be? 1 what? For number 1, are we going to be figuring out per dollar or per paperclip, Aiden?
figure out for a paper clip.
It says it right in the question. So that paper clips have got to be in the bottom then. That means money in the top. Okay? Which means down here it says for $1, so what's going to be my label in the bottom then? Dollars. In dollars, this is going to be paper clips, right? Now we're going to put our fake ratio on there. That is that $3 for 15 paper clips. What am I doing to my number of paper clips? Dividing by 15. So what do I got to do up here? Divide by 15. We end up getting 0.2. Am I going to accept that?
No.
No, because money doesn't just go to one decimal place. You got to add the 0 and make it 20 cents. Down here, we put our fake ratio on there. Well, we got to make sure we flip it. That's why labels are so important. 3 is going to go there now. 15 is going to go there. What are we doing to our amount of money? So what do I got to do to my paper clips? Okay. This is going to be 5 paper clips. Now we've got to figure out which one makes more sense. And here's the deal. They absolutely both make sense equally. Here's why. I know some of you are saying, well, why would I ever buy one paper clip? Okay, that's not the point. But would it be possible, if I had 20 cents, could I come up with 20 cents to buy one paper clip? Yeah, 2 dimes or 4 nickels or 20 pennies, whatever. I could actually go get 20 cents. I could have partial money. Down here, if I had $1, could I go in and buy 5 paper clips?
Yes.
Absolutely. So they both make sense. What if this answer was like this, though? 5.4 paper clips. Would this one make any sense now?
No.
No, because you can't buy partial paper clips. Does that make sense? All right, good. Let's go on. Okay, guys, look. Hey, guys, look what it says here. It says write the ratio of triangles first, rectangles second. Again, it comes back to reading with a lot of you. A lot of you are doing 5 to 4. But guys, look. This is a good opportunity to do some edge pieces. Let's do our edge pieces here and let's say, okay, I see that there are 5 rectangles and there are 4 triangles. So if it wants to know the ratio of triangles first, then I have to list triangles first. That would mean 4 to 5 would be your answer, and we would write it with a colon, fraction form, and with the word 2 in there. Those are your 3 ways. Everybody got that?
Yeah.
All right. Go ahead and do this one. What did I ask you guys to do on this question? Yes? Put them in fraction form. So basically rewrite each of these ratios in fraction form. So it would look like this. It's easier to see when you do it like this. You have to trust us on this. It's so much easier to see it. Here, listen, guys. All right. So you have to see, what am I doing to 9 to make it become 45? Times 5. So it's not 10 times 5. You don't go back this way with it. You ask yourself, what times 5? What times 5 would give me 10? What times 5 would be 2? Okay? You got to make sure you think about it in those terms. Okay? As I look around the room, I see a lot of you doing 16, ABC 12. And in your calculator, it's going to give you this again. 1U and 1/3. Okay? Guys, you cannot, I repeat, you cannot have a mixed number in ratios. Ratios and fractions are very similar. You guys agree, right?
Yes.
There's a couple things that are different. This is one of them. Mixed numbers do not apply in our ratio chapter. So, you guys can either get it here and then go around the barn. That's fine. It would be 4 to 3. Now, I'm watching some of you guys, and it's fine if you do this, but I see some people saying, yep, I'm going to divide by 2, divide by 2. I'm going to divide by 2, divide by 2, and you get there. But just keep in mind, that's fine if you want to do it that way, but if you're going to check, I've given you the tool. 16, ABC, 12, it's going to give you 1 and 1/3, and then just go around the barn. It'll be in simplest form. Okay? It's fine. We've got to keep moving. I'm going to record so quiet. All right, so we're going to do this one here. What is that, everybody? That's your fake ratio. Now, this is, look, guys, watch my process here. I draw the proportion without anything on it. You listen?
Yeah.
I draw the proportion without anything on it. Since it's unit rate, I know it's unit rate because it says right there, per hour. So since that's a very typical unit rate, right? Anytime you're doing 1 of something, it's unit rate. And we're going to put our 1 there. Now we're going to build with labels first. So I know it says per hour, so that must mean that hours are going to go on the bottom, right?
Yeah.
Miles on the top.
Yes, sir.
Okay. Now where am I going to get the information for this part of the proportion, this ratio? Where am I going to get that, Caroline? The fake ratio, which is right there. Just make sure the correct number goes with the correct label. So 81 over 9. What am I doing to my number of hours? Yep.
Divide.
Dividing it by 9. So what do I have to do to my number of miles? Divided by 9. Right there. 9 miles per hour, right? Okay. Good. Let's go ahead and do this one. Everybody listen. So this one. These money ones are the ones that are going to get you guys. Not everybody, but some. We're struggling with money. Guys, if you ever get $0.5, is that a real amount of money? No. That is 50 cents. If you have this, a dollar sign, and then .382, is that .382 cents? No, it doesn't work that way. You always have to round. So this is either going to be 38 cents or 39 cents. What's it going to be? 38 cents. So let's, first of all, like I said, process here. Even though I'm saying this every time, some of us aren't getting it in. I want you to make sure you're hearing me. I know what's best. Trust me. I'm going to put a 1 there. Now I'm going to put my labels. Are we talking about per dollar or per pencil? Per pencil. So pencils on the bottom, money on the top. Now we put our fake ratio here, which is 750 for 12 pencils. We would be dividing by 12 to our number of pencils. We got to do that up here. When you divide that, and by the way, please use your calculator on that, you're going to get .625, right? That is not 625 cents. 625 cents would be this, right? 625 cents. 600 of them turn into $6. Make sense?
Yep.
Money only goes to 2 places. So this is either going to be 62 cents or 63 cents. So we have to look to the number to the right. We're always rounding to the hundredths. The 5 is going to tell the 2 to go up to 3, which is going to make this 63 cents. If you leave it as 3 places or 1 place on the test, I will count it wrong. That's a lot of a life skill, knowing that money goes to 2 places, being able to round to money. Rounding to hundreds. Everybody got me?
Yeah.
All right, good. So, right, this one here. If Mr. Edwards ran 3 laps around the track in 12 minutes, he ran 2,500 in 1 minute. Now, again, there's 2 ways to do it. I know how all of you are doing it, which I love. I'm totally cool if you do it like this. You all recognize that we're talking about unit rate per minute, right?
Yeah.
And then you are saying, okay, that would be per 1, and then we put minutes there, laps there, laps there. We put our fake ratio here, and then we would be dividing by 12, dividing by 12. That's where we'd get .25, right?
Yeah.
The other way that you could do it, not that I want to confuse you, but just giving you options, is I could look at this and say, okay, that's 3 laps for 12 minutes. And then the other one is .25 laps for 1 minute. And what I can do is I can use cross products. 12 times .25 is 3. 1 times 3 is 3. Simplifying them, that's the only issue here. Simplifying won't work with a decimal. So that's the only problem, but you can still divide them. .25 divided by 1 is .25. 3 divided by 12 is .25. So either way there, I think this way is the one you guys prefer, but either way there. Okay, so right here, there's obviously our, hey guys, listen please. There's our fake ratio there. Okay, so we're going to have to do 2 unit rate proportions. So there's 1, there's another one. 1's going to go there in both of them. Now, in number 1, is it asking for the cost per hat or the amount of hats per dollar? What's it asking for? Per hat. So we're going to put hat there, which means money on top, money on top. Down here, we're talking about per dollar, right? Per dollar. So then we're going to have hats on top, hats on top. Here, it's going to be $42 for 3 hats. We can see that what are we doing to our number of hats? So what do we got to do to our money? There's going to be $14 per hat. And then down here, it's going to be 3 hats for $42. We need to divide our money by 42. And then we would do divide by 42. That would give us .07. Okay, which one makes more sense here? Well, if I have $14, can I go buy 1 hat? Yes, but if I have $1, can I go buy .07 of a hat? No. So this one, obviously, guys, would make way more sense than the other one. All right, listen. Okay, this one, watch how I do this. I'm going to get my edge pieces out here. Guys, quiet. I'm going to get my edge pieces. I know that right there it says there are 12 markers for every 15 whiteboards. Then what I'm going to do is I'm going to write down what Mason said. I'm going to write down what Connor said because I'm just going to figure out what they said. And I look here and I see that Mason said the ratio of whiteboards he listed first is 12, and that he said markers second, which makes 15 the second number. So that means 12 whiteboards for every 15 markers, right? All right. Then Connor says the ratio of whiteboards. So he's saying there are 15 whiteboards and 12 markers, right, guys?
Yeah.
So based on what we're seeing now, who is correct here? Clearly not Mason, right?
Yeah.
He's flip-flopped, right? Connor has the 15 whiteboards. He has it right. And the reason why is because order matters.
What if I had Connor had it in the right order? That way.
Good. Good. I want to see. Good. I want to see the big three methods here, guys. So you need to tell me whether or not they are equivalent. So it's either yes they are or no they are not. Go. Are these markers really bad? I mean, you guys are throwing them away out of the
Very,
way.
very picky with that.
Well,
Because a lot of them still work.
that one doesn't.
Yeah.
I mean, I've seen more markers get thrown away.
Here's the problem.
It's almost like
I
they.
look over and I see people going like this. with them,
I know.
Try and get them to work.
That's my. I don't understand. And then they get shoved in. I don't understand. That one's fine.
Did I ever say Aiden was doing that?
That one's fine. It doesn't have to be like a perfect strip of, like. Come on.
Good. Here, let's move up to the front one. Let's go for the seats, okay? Right there, and then you're
Okay,
gonna write these down, okay?
Wait.
This goes losing brake lots. We're not following directions right now.
Look what I just made it very clear. Everybody in the room heard me except you have done.
What about Carly?
Are you allowed to just write yes or no?
No. No.
Has it ever been okay to just give us the answer, not tell us?
No.
Man, come on. It's all about the structure. That's all it is. Okay, remember there's something called cross products.
Okay.
You can simplify the two ratios or you can divide the two ratios. Because all fractions and ratios are division properties. Make sure you show what they want. Let's write down.
Okay.
I mean, that's the whole point. If they're the same value, then they're the same ratio.
You're gonna see pretty cool.
I see cross products. What about you didn't do division or
Yeah, I did.
you got to write it. Guys, hey, I have to see that you tried the big three methods, or at least two of them, tomorrow on the test. Everybody understand me?
Yeah.
If you don't show me that, it's wrong.
Cross products.
Cross products when you multiply the day.
Show you that.
I don't think the challenge showed me that yet.
Well, then she showed you like simple. You can simplify them.
Yeah.
They have to have the same
Do that.
simplified ratio.
Yeah. I'm so I'm gonna go get injuries.
Good. 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 Where's your division? You can divide 8 divided by 9, 9 divided by 10. Right?
We went over this.
It might not. That's
If
the whole-
that means if they did, then they're not equal.
If you got 80 here, and you got 81 here, that means that told us that it is no.
So if they don't go into each other, Myra, that's a good thing. You just figured out that they did.
Now simplify it.
Really, it's cat day.
Now simplify.
How do you
Did you divide them? What are they going to divide? No. You're doing it whatever way you want to do it.
That's fine. Don't show us divide like that. Show us as a fraction.
Guys, this is all I'm looking for right here. Check it out. Let me show you. The answer is no, which most of you got. Now cross products you're all getting. That would be 81. That would be 80. That tells us no right now, right? Then we can simplify them. Well, when you do 8 ABC 9 in your calculator, what do you get?
8, 9.
8 to 9. You get it right back. When you do 9 ABC 10 in your calculator, you get 9 to 10. So those are already in simplest form. So clearly they can't be the same, right? The last one is divide. Okay? And that is where you do 8 divided by 9. You don't have to show the division. And that's 0.89, right?
No, just 8.
No, it's 0.8 repeating, which is 0.89. And then 9 divided by 10 is going to give us 0.9. Are those the same? So we didn't get the same cross products. We didn't get the same simplified ratio. We didn't get the same answer after we divided. Therefore, the answer is no. Everybody got that? Oh, dude, that's been recording that whole time.